We are covering vector 2, and we are going to start with this question here, a question that was done in 2018, that is KCSE, and you'll be told that OP, it's vector P, the direction from O to P. We said that a vector should have an origin, a vector has a direction, and a vector has a magnitude. Origin is from O, direction is from O to P, and the magnitude is OP. Next, OR, we have Q there, R is there, and you'll be told that OR, it's vector R. Then we have S. You have also been told that PQ is to QR is equals to 1:2. The ratio of PQ, Q is to R, 1:2, like that. Then we have also been told that PS is equals to 3PR, like that. We've been told to express QS in terms of a P, vector P and vector R, like that. These are all, these are origin. PS is equals to 3PR. First of all, you can get PR. I want to move from P to R, but I cannot move directly. So from P to R is supposed to be, I will follow the direct route. PO plus OR is equals to PO plus OR, like that. And OP is positive vector B. The reverse of that, the sign will change from positive vector P to negative P. PO will be negative vector P plus OR will be vector R, and that is our PR. Then after that, we can get OS. We can get OS. Yeah, first of all, PS, you come here and say that PS, vector PS is equals to 3 PR, but PR is what? It is our PR. We can open the bracket and start with the positive vector R minus vector P, like that. Once you open the bracket, we are going to have 3 vector R minus 3 vector P. This is our PS. Then we have OP, and we also have PS. We can get OS. We say that OS is equals to OP plus PS. OS is equals to OP plus PS, like that. OS will be OP vector P, then plus PS is what? PS is here. We substitute 3 vector R, 3R minus 3 vector P, like terms. 3R, negative 3P plus P, it's negative 2P, and that is the OS. That is our OS. But the examiner wanted us to get QS. We express QS in terms of P and R. We know PR. You can come here and say that PR is what? PR will be told that PR 1:2. 1:2. You have the ratios 1 plus 2 is 3. You can say 3 is equals to PR is what in terms of vector? PR is here. It's 3 is equals to vector R minus vector P. Then what of PS? PS, do you know PS? Yes, PS is here. You can say we don't know RS. RS is what in terms of ratio. You can say RS, it's X. First of all, we assume that the PS, you know that PS is equals to 3R minus 3 vector P. We can say from P to S, it's X. Correct, we say it's X. From P to X in terms of the addition. 1 plus 2 PR, 1 plus 2 it's 3. But the ratio by the vector PR is equals to R minus negative P or negative P plus R. From P to S we don't know. You can say it's X is equals to vector from PS, it's here, 3R minus 3P. First of all, you want to get the ratio of RS in respect to PS. We can multiply and say 3R vector R minus 3 vector P is equals to X R minus vector P, like that. You open the bracket and say 3 times 3R it's 9R minus 3 times 3P it's 9 vector P is equals to vector Rx minus vector Px. R and R you equate. 9R is equals to vector Rx. R and R you drop, and X is equals to 9. Let's prove whether we are going to get X with the P. Negative 9P is equals to negative Px. You can drop P and P, you drop negative and negative, because negative you divide by negative is positive, and X will be 9. What this means is that from P to S is supposed to be 9, but PR is 1 plus 2, which is 3, but the whole of it is 9. You can say 9, you can say that RS is equals to 9 minus 3, which is 6. RS is 6, correct? Yeah, that's how you do it. Then after that, we are going to come here and say that express QS. You can come here and say that QS is equals to 2 plus 6 all over total PS. It's 9 into bracket PS of PS, like that. And this is supposed to be 6 plus 2 8 over 9, but PS is what? This is our PS. You substitute, you can open the bracket and say 3R, 3 vector R minus 3 vector P. Open the bracket by 3, 1 by 3, 3 to get 8 over 3 vector R minus by 3, 1 by 3, 3, 8 over 3, 8 all over 3 vector P. That's what the examiner wanted us to do. That is that. You can proceed to another question, Roman 2, where you've been told that vector RS, vectors R and S are such that R is equals to 7I plus 2J minus K, and S is equals to negative I plus J minus K. Then the examiner wants you to find R plus S. and this means magnitude. Magnitude, we are going to come here and say, put the square root, you open the bracket, you take 7 plus, 7 plus minus 1, this one here. You replace it with 1, it's like you have 1, then squared, plus 2, j and j, j for r and j for s, 2 plus 1, like that, you have 1, and find the squared, plus, then the bracket, negative 1 for k's squared. And here we are going to have 7 minus 1 is 6. 6 squared, like that. 2 plus 1 is 3. 3 squared, plus negative 1 is negative 2. Negative 2 squared is supposed to be positive 4. Negative 2 squared. And we are going to have 36, 6 squared is 36, plus 3 squared is 9, negative 2 squared is 4. This is supposed to be root 49, and square root of 49 is supposed to be 7 units, and that is the correct answer for that part. That is the correct answer. Next, I will have this part here, your vectors. You've been told that the position vector, vectors O, vectors of point P, Q and R are, you can say that for P, in terms of column 1, negative 1, 3, comma, for Q is equals to 3, 3, 1, and for R will be, open the bracket, 6, 9, negative 2. You've been told, show that PQ and R are collinear. You are supposed to show that they are collinear. What we are going to do, we are going to draw a triangle so that we can show the origin of this vector, origin, magnitude, origin, magnitude, and direction. A vector should have an origin. You can say our origin is O. Let's say this is our P, and our P will be told it's 1, negative 1, 3. It's here. Then we can also say that we have Q it's here, with 3, 3, 1, and R 6, 9, negative 2. That being the case, what we are going to do, we can say, let's say that PQ, what if we say that PQ, vector PQ is equals to, first of all, we say that PQ is equals to, we can say like H, HPR. HPR. Let's see what we are going to get. PQ, we start with Q, 3 minus 1, 3 minus 1, 3 minus 1, 1 minus 3 is equals to H. First of all, you can get H, which is supposed to be constant. PQ, P and Q start with, PR we start with R. R is what? 6 minus 1. 6 minus 1. 9 minus minus 1, 9 minus minus 1 here, then negative 2, negative 3, yeah, like that. Then we open, 3 minus 1, it's 2, 2 is equals to 6 minus 1, it's 5, then hash, hash will be what? You divide by 5 by 5, hash will be 2 over 5. Next, 3 minus minus 1 is positive, negative and negative is positive, so that 3 plus 1 is 4, 4 is equals to 9 minus minus again positive, 9 plus 1 is 10, is equals to 10 hash. Hash is equals to 4 divided by 10, and this is supposed to be again 2 over 5. We have said that hash is supposed to be constant to all. Next, 1 minus 3, it's negative 2, is equals to negative 2, negative 3, negative 5 hash. You can divide by negative 5 by negative 5. And you are going to get negative and negative is positive, and hash will be, comma, hash will be 2 over 5. Yeah, that hash is supposed to be constant. It means PQ is equals to hash now is what? Because it's constant, you can say 2 over 5 PR. Yeah, like that. Then after that, you can come here and write, yeah, you can come here and say that PQ, then QR. So I can wrap this part here so that you can proceed. Yeah, in terms of ratio, PQ, you can multiply there by 5, by 5, by 5, 1, by 5, 1. And we are going to have 5 PQ is equals to 2 PR. In terms of ratio, PQ is to, yeah, PQ is to PR, this is R, is equals to PQ goes with 2, the number in the opposite side. Then PR, this is PR, goes with the number on the opposite side, and it's supposed to be 5. If you are to come here and say PQ now, it's 2, so that PR, P and R is 5. The total of it from P to R is 5, which means Q and R, QR it's 5 minus 2, and it's supposed to be 3. And you can come here and say that PQ is 2, QR will be what? PQ is to QR, this is supposed to be 2 is to 3. PQ, QR, yeah, PQ, it's, we are expressing it in terms of column. PQ and QR, they are collinear. Say that Q is a common point. Yeah, Q is a common point because here we have Q and here we have Q. So Q is a common point. Hence, PQ is to QR, R collinear. Yeah, that's how you're supposed to express that. Correct. Next, you can have a 10 marks question again on vector 2. On vector 2. You've been given this triangle here. Then we have a line that meets y there. We also have a line that meets OA at x. You've been told the figure below, OA, this is our O, this is our A. OA is vector A. That direction is supposed to be vector A. OB, B it's here. OB, it's vector B. Like that. And BX, yeah, X was here. X is here. This vector A, this X, and BX meets O up Y. Y it's here. Then you have C there. OX, OX, OA, OX, and OA, it's 1:2. OX is 1, so that O to A is 2. It means XA will be 2 minus 1, because OA is 2, and you know that OX is 1. We are going to say 2 minus 1 is 1. So that OX is supposed to be equal to XA. Next, and BY is to YA. BY 1, it's YA 1:3. This is a question that was done in the KCSE year 2020. Then, that being the case, we have everything there. You've been told you express Roman 1 BA in terms of A and B. Good. BA, we want to move from B to A, but you cannot move from B to A directly. So we need to get a root. BA is equals to BO, vector BO plus OA, or A like that. But BO is what? From O to B, it's positive vector B. It means the reverse of it will be vector negative B. Yeah, from O to B, positive B. BO, then the sign will change to negative B, plus OA. OA is vector A. The way it is positive. You can even start with the positive vector A minus vector B. And that is the answer for that. Roman 2, O, Y. Why is Y? Y it's here. We are going to say we want to move from O to Y, but you cannot move directly. So you can use the root OA, AY, or OB, then BY. OY is equals to, we can use OA plus A or Y like that. But OA is what? OA, it's vector A plus AY. AY is supposed to be 3 in terms of ratio. 3 all of a total 3 plus 1 is 4 of AB. Vector A plus 3 over 4, but AB is what? AB. Can you see here you have BA and you want AB? That being the case, it means we are going to come to this BA. While we have positive, the sign will change from positive to negative, from negative to positive. Yeah, AB, and we want BA and we want AB. Then it means we start with negative B will be positive vector B. Positive A will be negative A, like that. Then you open the brackets. Vector A plus 3 over 4 vector B minus 3 over 4 vector A, like terms. A minus 3 over 4A is supposed to be a quarter vector A plus 3 over 4 vector B. That should be the correct answer for that part. Next, you've been told BX, Roman 3, BX. Why is BX? BX is here. You can use BX, you can use the root BA, AX, or BOOX. X use BOOX is equals to BO plus OX. like that. But BO is what? BO from O to B is for positive vector B. The reverse of it will be negative vector B plus OX. OX is equals to 1. From O to X is, in terms of ratio, is 1. All of a total. From O to A, it's 1 plus 1 is 2 of OA. And this will be negative B plus a half, but OA is what? It's A. Yeah, that is our BX. Good. We proceed. To part B. Yeah, part B carries the major, the largest share of the marks. Part B, you've been told that OC it's H, OY, and BC is equals to K, B, X. Determine the values of H and K. Yeah, this is 6 marks. This was 1 mark. This was 1 mark. We had 2 marks, and this is 1 mark. Then the marks are on part B, and it's simple. We are going to come here. Why is OC? OC is here. OC is there. Why is BC? BC it's there. In this part, what you are supposed to do, you are supposed to identify a root in which you are going to incorporate both OC and BC, so that after that you can form 2 simultaneous equations. Those 2 simultaneous equations will help you to solve the value of H and K. Yeah, I have put these commas, these apostrophes, so that you can see the root. Here we have O, C, and B. It means the route that you can follow, or if it's a shape that you can use, is a triangle. Triangle OBC. OBCO. Yeah, that's the triangle that you are going to use, so that you can incorporate both. And you can say that OC, OC is equals to OB. Yeah, OC is equals to OB vector plus BC, like that. Then you've been told that OC, it's H or Y. You substitute where you have OC, you substitute with H. But your Y is what? You come here. We have solved that. OY. This is our OY. You open the bracket and say a quarter vector A plus 3 over 4 vector B, like that. What of OB? OB is vector B, positive vector B, like that, plus BC. BC, you've been told it's K. You open the bracket because you need to find the value of BX, but you had computed the value of BX. It's here. We start with the negative vector B plus a half vector A. Then after that, this is vector B. Then after that, you can open the brackets. A quarter vector A H plus 3 over 4 vector B H is equals to vector B plus, yeah, here we are supposed to have a negative vector B K plus a half vector A K. Yeah, that being the case, we can pick where we have vectors A. Here I can see A, there I can see A, and there we have A. We are going to say a quarter vector A H is equals to a quarter vector A K. You can drop vector A and vector A. and a quarter h is equals to a half k. LCM of 4 and 2 is supposed to be 4. You can multiply that by 4, by 4, by 2 and by 2, 2, by 4 and by 4, 1. And h will be what? H is 2k. This will be our simultaneous equation 1. Then you go to B's. B and B. We say that 3 over 4 factor BH is equals to factor B minus factor BK. B is common. You can take B outside the bracket in this equation to say that factor B, 3 over 4 H is equals to factor B. Once you have taken factor B outside the bracket, you'll be left with 1 minus B factor B K. You divide by factor B, you'll be left with K. K alone. You drop factor B and factor B. Come here and say that 3 over 4 this H is equals to 1 minus K. This will be your equation 2, like that. This being your equation 1 H, you are going to substitute your H in here in equation 2. You say that 3 over 4 times 2 K is equals to 1 minus K. By 2 and by 2, 2. 3 over 2K is equals to 1 minus K. You can multiply that by these 2 times 2 times 2 times 2. And you are going to have 3K. 3K is equals to 2 minus 2K. Like terms, negative 2K from right to left. 3K plus 2K is equals to 2. 5K is equals to 2. And K will be 2 over 5. You come and substitute it here to get the value of H. H will be 2 times 2 over 5. This is supposed to be 4 over 5. Yeah, this is our value of K and H. Let's see whether it's making sense. You are going to come here and substitute. You say that OC is equals to H. H is 4 over 5 OY. You can multiply by this 5 here times 5. So that by 5 1 by 5 1, 5 OC is equals to 4 OY, like that. In terms of ratio, say that OC is to OY. For OC goes with the number on the opposite side and not 5. So OC will be 4. Then OY goes with 5. And we come here and prove whether correct or wrong. OC, yeah, O from O to C it's 4. OC is 4. So that from O to Y total is 5. It means CY will be 5 minus 4, it's 1. Like that. So that one is correct. Next, we proceed to the other one. It's here. Yeah, for K. BC is equals to K, but K is 2 over 5 BX times 5 times 5. 5 BC is equals to BX, like that. In terms of ratio, BC is to BX is equals to BC it's 2, the number on the opposite side, and BX is 5. Let's see whether correct. BC, yeah, BC it's 2. So that from B to X total it's 5. It means CX will be 5 minus 2, 3. And that's how you're supposed to do that question. Thank you for today.